Hi, and welcome to day 11 of polynomials. And today we're talking about overcoming obstacles in factoring. So the first obstacle we're going to overcome is the first problem because it's not factorable, so we're just not going to do it. Okay, that just happens to be how this one is. We're skipping number 1. And then we're skipping part of exercise 1. Oops, let me get my pen back. And we're going to X out the first problem there, first part of the equation, because we're not going to work with that one again. It's not factorable. And I really just want to focus on 3x squared plus 8x minus 3 equals 0. And we're going to do this by factor by grouping like we did on the last video. So 3 times negative 3 is negative 9. My factors of negative 9 are 1 and negative 9, 3 and negative 3, and negative 1 and positive 9. Now I need to see which pair gives me a positive 8x. Well, that would be that pair there. So I will have 3x squared minus 1x plus 9x minus 3 equals 0. Remember, all I'm doing is breaking it down so that I've uncombined my like terms. So I'm going to group and group. Factor out an x, see what they have in common, so it's 3x minus 1, and then the second one, I'm going to factor out a 3, so plus 3, and I'm left with 3x minus 1. So the parentheses that I have in common are 3x minus 1, so that's my first factor. My second factor is x plus 3, and then just set each factor equal to 0. So I'm just going to move over here. So 3x minus 1 equals 0. Okay. It may look like I backed up. I apologize. When I hit record, it didn't record. So I'm going to go back through this. So if you already have this written down, then don't worry about it. Just listen again because it's always good to talk about factoring by grouping. 3 times negative 3 is negative 9. 1 and negative 9, 3 and negative 3, negative 9 and negative 3 are my factors. I'm trying to undo my middle term. So I have, hang on. Okay. 3x squared minus 1x plus 9x minus 3 equals 0. I'm going to group and group. They have an x in common, so I have 3x minus 1. Here they have a 3 in common, so we have a 3x minus 1. So now that my parentheses are the same, I have 3x minus 1, and what's left over is x plus 3. Now I set each factor equal to 0. So I have 3x minus 1 equals 0, x plus 3 equals 0. And I'm going to add 1, so I have 3x equals 1, divide by 3, so x equals 1/3. Here I'm just going to subtract 3, so x equals negative 3. So x equals 1/3 and x equals negative 3 are my roots, or solutions, or zeros. All three of those words mean the same thing, roots, solutions, and zeros. So for the next one, it looks like the second step there in the factor by grouping where I already have 4 terms. So since I have 4 terms, I'm going to do my factor by grouping. And these two have an x squared in common, so I have x plus 3. Here we have a negative 9 in common, so I have x plus 3. When I'm done, so I divide by negative, it becomes positive. So they have an x plus 3 in common, and here I have x squared minus 9. And that is a difference of 2 perfect squares. So that becomes x plus 3 times x minus 3 equals 0. So this is really x plus 3, the quantity squared, times x minus 3. And here, if I were to set each factor equal to 0, I'd get x equals negative 3 and x equals positive 3. And so this x equals negative 3 is a multiplicity of 2, because I have 2 of them, 1 and 2. And then x equals positive 3 just has 1. Find all real solutions. Again, I have 4 terms, so I'm going to group. So I have x squared times x minus 5, and then I have a negative 4 in common, so it's x minus 5. So they both have an x minus 5 in common now, so I'm left with x squared minus 4. So I have x minus 5, x plus 2, x minus 2, because that was a difference of 2 perfect squares. If I set each one equal to 0, I'll have x equals 5, x equals negative 2, and x equals positive 2. So we can write this as x equals 5 and x equals plus or minus 2. And then finally, for the last one, find all real solutions. Again, I have 4 terms, so I'm going to group and group. So they have an x squared in common, so I have x minus 8. Here they have a negative 2 in common, so I have x minus 8. So now they both have an x minus 8 in common. Then I'm left with x squared minus 2. That is not a simple difference of 2 perfect squares, or maybe it is. If I were to set that over here, set it equal to 0, so x squared equals 2. Sorry, that's a, yeah, positive 2. If I were to take the square root of both sides, I'd have x equals plus or minus radical 2. Well, that's exactly what I had up here in this one. I have x equals plus or minus 2, not radical 2, but 2. And I had 1 plus 1 minus, 1 was a 2, 1 was a negative 2. So I can actually break this down into x plus radical 2, x minus radical 2, because I'm treating it as the difference of 2 perfect squares, which essentially I take the square of the first term, take the square root of the second term, which is what we did right there when we were solving. So that means x equals 8, x equals negative radical 2, x equals radical 2. So we have x equaling 8, and then x equaling plus or minus radical 2 as our roots. So that is basically it when it comes to overcoming the obstacles in factoring. Because of the obstacles we chose to do today, it wasn't too bad.